Good afternoon, ladies and gentlemen. Welcome to another edition of IICD Talks. It's a pleasure to have you all here. Today, we'll be exploring the fascinating topic of artificial intelligence and its applications in design. Joining us for the session are esteemed professors Stan Ruecker, Juan Salamanca, and Ricardo Codinhoto. Each of them will present their talks with a time limit of up to 20 minutes per presentation. After all three presentations, I will open the floor for questions for the audience, giving everyone the opportunity to engage and clarify any doubts. I hope you enjoy today's event and find the discussions insightful and inspiring. Thank you for being with us, and let's begin. So I'm going to allow you to share your screen, okay?
Great.
Since we have a presentation, or I'd like that I share the one you...
No, I can, I've got one here.
So, okay, so just before you start, let me introduce you. So hold on a second. So Dr. Stan Ruecker is an international design research consultant. He was a design professor for 20 years with tenure at 3 prominent universities. Prior to that, he was a design consultant for 10 years and also a computer programmer and manager, focusing on artificial intelligence and business systems. Dr. Ruecker has written extensively on design and the digital humanities with over 170 articles and 4 books. Much of his research has focused on the future of reading. Research teams have developed more than 24 prototypes for use in supporting the interpretation of texts. He's currently working with themes on the difference between university design, school education, and industry needs, and agile action research methods for use in university-industry collaborations in Society 5.0. Having spent more of his life in the colder parts of North America, he now lives in Medellin, Colombia, which now as the city of Purple Spring. So, everyone, let's receive Dr. Stan Ruecker. Thank you so much, Stan. So the stage is yours.
Thank you, Mauricio. Thank you, everyone, for taking the time to sit in. And especially hello to everyone who has 3 feet of snow. My brother, who still lives in Saskatchewan, wrote and said, it's ridiculous this year. So I'm so pleased to be in such a warm, beautiful city. So my talk today, University of Research and Design, I've spent a lot of time thinking about the role of designers in producing new knowledge. And it's interesting to me because it seems to me that part of the normal design process, especially if you're a user-centered design, is to do research. Every designer is a researcher. So what is the difference between, doing design on a project and doing design at the university for publication, for what I call adding to expert knowledge? And I think that's the key. So in the talk, I'll talk about the different kinds. I'll talk about design topics, methods, and how to do a project. And then right at the end, I'll talk a little bit about AI and how it can be used in the various stages that we've gone through. So this provides the framework for the thing. On the left, we have the practicing designer. They do user-centered data collection. On the right, we have the research designer. They do user-centered data collection. The difference is usually for the practicing designer, it's the client that you're working with, whereas for the scholarly work, it's the research that you're working with. There isn't necessarily a client involved, although there can be. The main difference, though, is the goal. On the left side, the practicing designer is hoping to make a new product or a service or a communication some design outcome. And on the right, the design researcher is looking to make new expert knowledge. That's important for students to understand because it means several things. First, you've got to know what the experts already know, and then you've got to try to add to that. So you become an expert plus in doing the research project. It's not enough that you get knowledge that you didn't have before. You have to get knowledge that the specialists in your area didn't get before. And one way to do that, so you have to collect data. You get enough data as a practicing designer to make choices in the project. If you have to convince anyone, you're convincing yourself or you're convincing your client. Whereas the research designer, you have to have data that's robust enough to convince the other experts in your field. So you might use the same data collection methods, but typically you're getting more data, deeper data, richer data. And again, it's addressing your research question as opposed to addressing the need to develop a new product or service. So those are the primary distinctions. When I say expert knowledge, I mean the relevant experts that you would see published if you're working with the university. Your advisor or committee members, your colleagues might be able to help you find out who's an expert in the area you want to work at. You look at the journals, you look at the conferences, and what you're trying to find out is what's already known. Some people say you're trying to fill a gap in the knowledge, but I think that's a little risky because I've seen cases where there's a gap in the knowledge because it doesn't need to be filled. So for instance, I had a colleague who did a PhD in the game design, and the advisor told him, well, there's a gap in the knowledge about about what is the difference between an expert game player and a novice game player. And of course, he found out that the expert game player had skills in practice and, all the things that are immediately obvious. There was nothing really important enough to have dedicated 2 years of his life to, and he was quite disappointed at the end. So I tend to say, just, find out what they know and then add to that, or, look at something that's important enough for the project. And then what can you add as a researcher? Well, look at how much time you've got. For a dissertation, you've got a couple of years. As a faculty member, you could have anywhere from 1 semester to 10 years, depending on the scope of the project. What kind of resources? Do you have funding? Do you have a team, or is it just yourself? And then what are you interested in? So that's how you go about kind of choosing what to focus on. Some experts, so now we're looking at what are the topics, what can designers conceivably choose to work on as a subject matter. So it's, personal interest, time, and resources, but also some really, clever thinkers in our field have said, well, here's how it's a design project. They're studying design itself. They're studying the people who do it, the designers. They're studying how they work, and they're studying the outcome of their design process. So if you're doing one of those 3 things as your content area, by definition, no matter what data collection methods you use, it's a design topic. I would say, so I'm in this last sentence here, any topic is fine. Designers, in the course of working for clients, deal with all sorts of topics. Why shouldn't the researchers? But you need to be using design-based research methods in those cases. So if you're looking at something that is, biochemistry or psychology or math, you have to look at it through the lens of a designer, which usually means user-centered design methods. Now, across the university, there's probably half a dozen or more ways that people do research. And design, I think, has its own way. It's one of those half a dozen. But they're related often to either the sciences or the humanities. So those are the 2 that I'll do here. For science, the goal is to show some connection between your independent variable and the dependent variable. If I change the independent one, does the dependent one change predictably? So if B happens after A, you want to show that that's probably not going to happen unless A actually is influencing B. So you start with a theory, you create some hypothesis around that. From the hypothesis, you get some research questions. Then you choose the data collection. And then they call this attempting to disprove the null hypothesis. And the null hypothesis is that, it could have happened anyway. So you're trying to show, no, it could only happen under these conditions. The humanity is quite different. And I think this is somewhat closer to what we tend to do in, it's kind of a hybrid model between these two in design. Enrich the object of study with a theoretical perspective means you learn how a school of thought has looked at texts. So they might be people who read very closely. They might be historians. They might be feminists. They might be post-colonialists. Whatever school they come from, whatever theoretical perspective they come from, then you choose an object of study that people in your theoretical school haven't already covered extensively, and apply the theory to make up an argument about the text that you're studying. So my wife, for instance, did a project on why is it that breasts are so important in modern life, looking at the 18th century. And so she read a bunch of literature and a bunch of medical and sort of contemporary nonfiction, and came up with a theory around embodiment in the 18th century. And it was this argument between midwives and nurses and people like that, who had always dealt with women, and the medical profession was starting to say, no, we're the ones that are going to be in charge of childbirth and nursing and all those kinds of things. And it was in the tension between those two that they developed what she calls the monstrous breast. We're fascinated with breasts because we're kind of scared of them. So that was the humanities approach. In terms of data collection methods, I think design can, again, in the same way that we can do a science-based study or a humanities-based study or a pure design study, we can also do data collection methods that are borrowed from those other fields, typically the social sciences, because we're looking at people. I would say what a designer is doing is creating a tool to help somebody accomplish something. So in order to do that, you kind of got to know everything you can know about the person and what they're hoping to accomplish, so that you can produce the right kind of tool. And the tool might be, an industrial tool, but it might be a communication tool or a system or, anything else that designers make. So then we can borrow these methods for trying to understand people. You can collect numeric data, quantitative data. Typically, you collect qualitative data because you want a rich understanding. I know Dr. Salamanca, when he did his dissertation project, used a mixed method. So he had some numeric data that he analyzed and some qualitative data. Or alternatively, now you can use design-based methods. So Herbert Simon famously said, designers should only do projects on optimization. Everything you're looking at has already been designed before, so how do you study it to make it better? And David Sless down in Australia does those same kinds of projects, but he's got a method where he takes a benchmark of how the current thing performs and then changes it and then does that benchmark over again to see that it's improved. I think the most important thing that designers use is prototypes. And what we really want to be able to do is say, okay, here's something that I've designed around my research methods or around my research topic. And studying that prototype is going to help me study the project. There's an interesting paper, if you've never seen it, in 1989. Friscara was one of my doctoral advisors. 1989, he wrote a paper called Is Design a Fine Art or a Social Science? And most of the people in the United States still haven't read it. So there's a lot of thinking of design as a fine art, which is about personal expression and about emotional engagement, but not necessarily about making a tool for somebody to accomplish something. In the sciences, I say they start with a theory. We have a few theories, but in general, not enough. So that's a nice thing for design researchers to be doing, is developing new theories. We don't really have a standard body of literature. We don't really have standardized teaching methods. We're still what they call pre-paradigmatic in the research area. We don't have enough standardized things yet. There are things like NAMSU's axiomatic design for systems theory, which is specifically about the design of technical machinery. But in general, I think I couldn't name more than probably a dozen or half a dozen design theories that people can build their work on. I have this little thing about 6 steps to doing a research project. You start in the bottom left by setting your goals. You know nothing. You do your literature review. Well, now you know what the experts know. Then you make something. So you know how to do prototyping. So you start doing some of that around your questions. Then you start trying to figure out what those prototypes mean in terms of the questions. With the analysis, you come up with some results. And then based on, on your work, you can now say, okay, here's advice I can give to future designers and to other experts in the field. I have some suggestions. So that's the kind of steps I talk about when I'm dealing with a graduate student that's just starting to learn about doing research and design. And I think it provides a nice outline of how I think. And finally, uses for AI. I think you can almost use it in every step. So there are tools now, things like RFlow and Storm that can help with the literature review. There's prototyping questions that you can ask to things like ChatGPT, data collection methods. We have a colleague, Jerry Dirksen, who just did a doctoral project where he built a prototype for children with autism to play with that used AI as a method for improving the interaction with the toy. So the artificial intelligence was built right into the prototype. Data analysis, of course, those are the standard, not generative AI, but analytical AI. Diagrams, you've got things like Dolly that can create images that you can use as part of your doctoral work or your article illustrations. With drafting of the thing, it's interesting, medical literature in around 2021 or 2, whenever it was that ChatGPT became popular, you could look at the graph and see a tremendous rise in the number of giveaway or keywords that ChatGPT likes to use that started to appear in the medical literature. So clearly they were using it to draft things and they weren't cleaning it up quite the way that I would tend to do myself. And then finally, a very painful, horrible thing that all people have to do is format the bibliography for where they're publishing. And now you can just dump whatever you've got into AI and say, put it into MLA or APA or whatever, and it can do a pretty good job. So I think just in terms of labor reduction, that's probably the one thing that I've been really happy to have available to me. And that's all I have to say.
Thank you so much, Stan. So let's keep the questions to the end of all presentations. Wonderful presentations. Thank you once more. Now I'm going to call Dr. Juan Salamanca. Dr. Juan Salamanca is an assistant professor in the School of Art and Design at the University of Illinois at Urbana-Champaign. His research sits at the intersection of design, social sciences, and informatics. His current research at the Design for Social Viscosity Lab at the University of Illinois is two-sided. One strand investigates the social and material conditions necessary to foster or hamper cooperation and collaboration in collective practices, such as urban commuting. His recent publications discusses the concept of social viscosity and introduce the use of agent-based modeling as a tool for studying it. His subsidiary research strand explores the visual analysis of large datasets for achieving unplanned collective goals in responsive contexts such as smart cities. Dr. Salamanca is an affiliate professor in the informatics program of the School of Information Science and the Civil Center for Design and at the University of Illinois. He holds a doctoral degree from the IIT Institute of Design, Chicago, and MDS in Design Direction from Domon's Academy in Milan, Italy, and a BA in Industrial Design from the Universidad Javeriana in Bogotá, Colombia. So everyone, say hello to Juan. Juan, thank you so much for being here. Now the stage is yours. Thank you.
Thank you, Mauricio. I'm wondering if I'm sharing the right screen. You see
Oh, you are not. You are showing the other one. You need.
the other one?
Yes.
Is that
Now.
better?
Yes. Now it's correct.
Okay.
Okay.
Okay. Thank you. All right. Okay. Thank you, Mauricio, for the introduction. I'm so excited to be with you today. And thank you for everyone in the room. So I'm going to quickly present my slides. This is about a research that I've been conducting for quite a while. Essentially, like trying to like envision how we can design some artifacts that may help people do things together, especially in situations in which people don't need to coordinate or they don't coordinating with some others is expensive in terms of like the time or the logistics to do the coordination. So I'm specifically like interested in the design of these elements as the social agents, but I'm going to talk today about this, how these social agents may actually learn from social interactions. And so I'm thinking these social agents might be computational artifacts that have some capacity to learn from the interactions with others. And so I'm going to focus exactly on that aspect. And I want to start with an experiment that was made it was actually made in 1972, but was published 20 years later. And this is an experiment conducted in like perception of colors. This was made by Dr. Roger Shepard, in which they ask participants to sort two kinds of pieces of information. First, they provide participants with cards with a pair of colors, and they ask participants sort the cards by what your perception of the similarity between the two colors. So in this list on the left, you see an example of cards with red and orange, red and yellow, and so on. And people have to sort that from the most similar to the least similar colors. And then they had to do the same thing with just color names. So not seeing the color, but just the color names. And with that data, Dr. Shepard come up with a model of analysis. It's called multidimensional scaling. But what is coming out from that model of analysis is that people, in order to organize this information, either by seeing the colors or by reading the color names, they have a similar mental model in their brain. And the mental model is the color wheel. What you see here on the right is more or less the Newtonian color wheel. So Dr. Shepard basically proved two things. One is that we share the mental model, the color mental model. The second thing is that there is an isomorphism, or the structure of what we see and we cognitively remember about reality. It has similarities in terms of the shape. And the shape for colors has this like circumference shape. Well, that is something I use as an inspiration to create a computational model. And the computational model takes an observation from reality and then translate that into a verbal model, like explaining in words what I observe. And then those words become a computational model that I use later to interpret the output of that model, and finally try to create interventions or implementations in real life. That's pretty much the methodology I follow in my lab. And so I invited people to do the same experiment, but instead of like people organizing pairs of colors, I asked people to impersonate a color. So I told, you are red, you are green, you are yellow. And then I asked people to interact between themselves, trying to stay as close as possible to similar peers and as far as possible to people with different colors. And you see on the screen the process. The output is surprisingly the same output of Shepherd. People arrange themselves by color proximity in a color wheel. So it's a way of like observing how people really have this kind of like mental model. And I translate that into a process in which basically I verbalize the operation people follow in these three steps. The step of perception, when they see other people, they compare the distance they are and then relate that perception with a cognitive model related to the distance, like the proximity, like the idea of like being close to someone is directly related to the similarity between the colors they are impersonating. And finally, an action model that is like walking towards or staying far from others. So that cycle, perception, cognition, action, is something that is my representation, my verbalization of what people are doing. And that is what I implemented in a computational model. Here we see the computational model running in two different conditions, in which every little dot is a person and they are getting close to each other as they like observe reality and follow that perception, cognition, action cycle. The difference between the left and the right is how many people I am interacting with. So if I am interacting with less people, I have a fragmentation. I never converge on a color wheel. So like some nucleus of similarities, but I'm not really converging with others. If I have an interaction with all the people around, I have this possibility, like creating a color wheel, but it depends on how many people are around. And other factors that I have to like save for later, maybe this due to the limited time. But I want to show here at the bottom, we have this curve that is showing the conformity, like how people feel in relation to others. And I call that social viscosity. Essentially, this line represents like my perception of reality is agreeing with my expectation. If it agrees, the level is low here. If it's a high disagreement, the level is high. So that's why progressively people find a place in this arrangement where they are happy and the people around are happy with them. Well, this is possible because we all have the same mental model. And this is part of a Western education. We are all trained with the same color wheel. And that unifies our color perception. But that is not the case like for all my other groups of people. And if you go do some research on, or I did some research on like linguistics and color names, and it happens that there are some groups of Aborigines, for instance, that speak Manic, and they have only 4 colors, 4 names for colors, or 6, including black and white. But this is not a problem of just verbalization, is that the way we speak conditions the way we perceive things in the world. So it's not that these people cannot perceive orange, because they don't have a name for orange. But by not having that name, it's conditioning the visual perception of orange. So they don't relate to that kind of like hue in a way. That is interesting because we assume that color wheels are like universal, like the Newtonian color wheel makes sense to be universal. It's derived from scientific research, but actually there's a lot of like cultural aspects that modify that. So let's say if we're going to design these artifacts need to be aware of that mental model. But what if the artifacts ignore that there are people from with other mental models in that community? If not everyone in the group shares the same mental model. So that's an interesting case where I use reinforcement learning to actually like make these agents learn the mental model. So instead of like putting the color wheel in the logic of these computational models, I am asking, develop your own mental model. And in order to do that, I use reinforcement learning. Right, still have 10 minutes. So imagine this is the situation. Do you have, try to imagine yourself, position yourself, put yourself in this situation that you're dressing a shirt, but you don't know what color are you. You don't know the color of the shirt. And people are trying to get close to you or far away from you based on the color of your shirt. But because you don't know your color and you ignore how people, what's the logic of people to like approach you, you need to develop that understanding from observing what people do. So that is kind of the situation here. You have some identity, you are projecting that identity. People have a way to relate to that identity, but you ignore what are the logics for that. So in this case, let's say this red agent has some ideas of like, okay, what is to be read, but doesn't know the relationship that other people may have. I need to figure out all this structure. So in reinforcement learning, what we do is this agent red is trying to figure out what is the right logic. And it starts with a list of random potential models. It chooses one and try that in the world based on a cognitive model and see what's the response of people. So based on that response, it gives some weight to that model and says, okay, it didn't work as expected. I'm gonna use another one that might be better, but I'm gonna give a ranking. So you see these like minus, 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 minus. So that's kind of like ranking these models. And by doing that, it's learning. Of course, this requires many iterations and many trial and error. But just by comparing what's the reaction of others to my current model, I can like validate that I am developing a model that is conforming. And there are some parameters in reinforcement learning that you can customize to explore more or to like go deeper into one model. But then those are technicalities. This is a simulation of someone who is yellow and is trying to figure out the right mental model. It's trying constantly. This is the mental model I've had, and what is interesting, this is the output, is that you see here on the right, you see the perfect color wheel. So red, orange, yellow, perfect in terms of the Newtonian color wheel. But this is the mental model developed by yellow. Yellow, as you see here, is not following the right sequence. Orange should be here, and green should be here. However, in this situation, everyone converged in a coral wheel. Yellow took more time, but even if yellow has an imperfect model, others accept that model because they managed to converge. This is the same case with a larger population. Here, this green in the middle is trying to learn. It's trying to learn. This agent has a problem. It's comparing with a limited group of people in that community. And they are accepting it to some degree, and then it's like there is a repulsion because it's trying a new model and trying a new model and trying a new model, but it's not comparing to the right people. It's like having that problem. It's not actually relating to the right people. Well, I'm saying people here, but it's in reality some agents. Apologize. I don't want this to be translated or extrapolated to like human interactions directly. Again, this is a situation. This is trying different models, and then it gets into a position where. So this is an analysis of the quality of the learning model, like that agent that is learning. Horizontally here, you see the number of people with whom, or the number of agents with whom that agent is interacting. And here in the vertical axis is the quality of what the mental model is. But this is from the perspective of, the left is the perspective of the agent. So how happy the agent is with the knowledge. On the right is the perspective of other people. And this is, on the vertical axis, we have the tolerance to imperfection. So the more tolerant in the upper part of the graph chart, the less tolerant in the lower chart. So there is a direct correlation between how many agents I interact and the tolerance of like those agents to my errors. But in general terms, the more I interact with people or agents, the better my model. But in the same case, the more I interact with others, I bother others more frequently. So that's the cost of learning is that I am going to increase the viscosity of the actions of people with whom I interact. So I think there's a tremendous potential for this method in the area of AI, because we need to interpret what is coming out of the computational model. It's what is exactly happening, and what is the perspective, for instance, of one single agent experiencing those interactions. We can get the output, what's better, what's worse, but actually, because we're using this agent-based model, we can understand the experience of someone through the process of learning. It's not if I learn or not. It's like the process of learning can give us tremendous insights for interaction design. Because again, it's not about just the output. It's about the process of getting the output, that it's something that we can observe. And I think large language models can actually give us a clue on taking some data in a latent space based on proximities, for instance, numbers of distances, and translate that into a latent space of words and create stories of what's the experience of someone and in that process of like developing these mental models. So there are many challenges. There are like, we have limited computational tools. We need like large computational models and large software that is more robust. What you see in this presentation was made with small resources. and that's why we have a limited number of colors. But if we were to try this in large populations, we need a larger computational facility. And we still need to like develop more and more like develop like more deeply the understanding of how can we translate the actions of someone in the simulators into stories or narratives that explain really what's going on in that system. So thank you for your attention.
Thank you so much, Juan, for your presentation. As I said at the beginning of this event, all the questions are going to be posted at the end of the 3 talks, okay? Thank you once more. So let's go to Ricardo Codinhoto. Ricardo, thank you once more for being here. Ricardo's research focuses on advancing design theory, practice, and education, with an emphasis on design cognition, problem-solving methods, and evidence-based design. His practical research includes applying building information modeling to facilities management and exploring design for health and well-being, supported by lean design principles. Ricardo's work, conducted through funding from EPSRC, ESRC, MRC, and NIHR, has significantly influenced policy and improved design and construction practice, with impactful projects such as hospital redevelopment, dimension-friendly environments, and linking building with service design. Expertise aligns with the UN Sustainable Development Goals, contributing to global sustainability and well-being initiatives. So, Ricardo, thank you once more for being here. So the stage is yours.
Thank you very much. Can you see my screen, just to confirm?
Yes.
Yeah, okay. Well, I'm going to go a little bit back to basics here today. So first of all, good afternoon, everyone, and welcome. And in this lecture, we'll try to explore, or maybe to speculate, how artificial intelligence is redefining design education and transforming the creative process. And so a lot of it is my thoughts about where we are, where we'll be going. So obviously merchandise first. I work at the University of Bath, which is a beautiful city in the UK, which is UNESCO World Heritage Site. And the university is a medium-sized university, but a powerful one. We are within the top 150 universities in the QS ranking. So where my interest in AI started was about 7-8 years ago. I'm no AI scientist, but I wanted to develop a digital twin to improve the waste collection system within the university. And I developed a digital twin, and I was trying to connect it to a robot wheel so it could be automated, right? And from there, obviously, with the explosion of large language models, I started thinking about what the impact it has in education. And 3 years ago, we felt, well, we need to do something more practical. And we created an MSc in Artificial Intelligence for Engineering and Design, which is an odd course in that is multidisciplinary. So you can come from the various disciplines of design and engineering, and you'll be sitting in the same class, trying to break up with the silos of information. And you look from problems, you're looking at problems from a multidisciplinary perspective and use AI to help to solve the problems. So obviously I don't know you guys, and I decided to go a little bit start a little bit basic here to talk about what is AI, right? And the standard model is simple. Machines are intelligent to the extent their actions can be expected to achieve their objectives. Yeah, so examples of AI is AlphaGo, SatNav, Automated Corporation, ChatGPT is another one. There's various models there. So the basic approach, right, is the basic model is what we call the black box model, right? Where one side, on the left-hand side, have sensory input, an objective. The data that Stan collected, for instance, presented through research, could be via sensor devices, could be various other ways. And in the middle, you have this big question mark, which is the processing model. How are we going to interpret the data that comes in, which could be the model that Juan was talking earlier. Yeah, and at that you have a prediction of what it entails or analysis what the data is telling you. Right, so this is the basic block for us to understand AI. So if you go a little bit back in time, what you see here is in that box, people put Fortran. And you may be familiar with the word Fortran. If you're quite young, you're not familiar with it, but you may have heard in the movie Hidden Figures, where they brought a supercomputer to NASA, and that becomes the machine that substitutes the mathematicians. Well, replace the mathematicians by people who can program. Yeah. So basically, Fortran was introduced, it was an evolutionary technique, introducing mutations and combining pairs of programs to create new programs. However, this approach performed poorly and failed to produce intelligent behavior. So I'm showing that as a result of something that didn't work. And it is worth noting that when it was tested, it had billions and billions of times less computational power than we have today. But it is a kind of logically good approach, and we keep wondering what would do if we use this approach again. So moving forward, this is a diagram based on a knowledge-based AI system function, combining logic, reasoning, and learning to make decisions. Is trying to make the black box a little bit more explicit, transparent, showing how perception, knowledge, and planning interact to drive behavior. It emphasized the evolution of AI and methodologies over time from logic-based reasoning to modern probabilistic and programmatic approach. It's quite recent approach. The issue with this model is that the system cannot separate truth from false truth, right? And anyone who studied a little bit of logic knows that this could lead to incorrect outputs. So, and deep learning is a most modern approach to AI, and it uses neural networks to optimize objectives from learning from data. Yeah, and it does that by using stochastic gradient descent, where models adjust to parameters by minimizing error on training examples to gradient descent techniques. So basically, look at the data, learn from it, refine, continue to learn from it, and so on. So this is the kind of a 2 minutes cover of kind of different types of AI and then what is in it. Here are some examples, right? Recent deep learning applications. So this is DeepMind AlphaFold, 2024 joint Nobel Prize winner. Google DeepMind developed AlphaFold using deep learning techniques to predict protein structures with near experiment accuracy. So basically, we move from finding the way the structure of proteins from like 1 per PhD to hundreds in one go, right? So it is a kind of a breakthrough in science. Yeah, this is what you see on the left. And on the right, what you see is the novel DeepDoc, which is another system based on the same principles, which creates new proteins that possibly do not exist or have not been mapped into the real world, right? But it would work as bridges of gaps in existing proteins, so therefore helping us to create new medicine, new treatments, and many other things. So again, so you see on the left here an aluminum scaffold for Excited Telescope, and that was produced in NASA. And on the right, Amazon humanoid robots, right? So and in Amazon, so the robot is leveraging deep learning for object recognition, motion planning, and human robot interaction to enhance automation in logistics. Again, so if you go back to the two presentations before, right, these robots, these things, they're collecting data, right, from the environment where they are, right, and then they have pre-programmed objectives, so they have to complete tasks, could be lift this box and take it to a target, yeah, and then they will learn how to interact with what is in the environment, because within the warehouse there will be people, there will be other smaller robots or robots of different types. So then you start to create this kind of interpretation of how you should interact in that particular environment. And again, on the same, here you see is the driverless car in San Francisco, which is like everybody now goes to San Francisco to be in one of those Uber taxis. And it shows also perhaps a less successful aspect of AI in deep learning models, which is the car stuck on concrete. Yeah, so basically the model could not differentiate wet concrete from dry concrete, so it drove through a road that is being repaved. So it's just to show that even though we are evolving quite fast, there's still quite some way to go. In the UK, driverless cars research kind of stopped 2 to 3 years ago, because overall there's a sense of insecurity by users. It would require a huge, extensive mapping, 3D mapping of our cities, and because the UK is quite old, some very narrow roads, some very weird systems. So it's just people believe that it's not ready for the UK yet. So there's the key question: can deep learning solve everything? And the answer is no, right? So they require very large functional representations. There's no saving in computation and massive increase in sample complexity. The processing of very large complex process is huge. So you may have seen on the news that I think Google is trying to create a new mini nuclear power station just to feed the new AI processing computers, and above all, right, we are limited in the way we can set objectives for computers to complete. Yeah? Machines by themselves, they do not have objectives of their own. We build objective achieving machines. We feed them objectives into them or specialize them for particular objectives, and off they go. And why is that a problem? Because there are limitations in the way we set up problems for AI. So here I borrow an example from Professor Steve Russell. Suppose, for example, that COP36 asks for help to de-acidifying the oceans. They know the pitfalls of specifying objectives incorrectly, so they insist that all the byproducts must be non-toxic and no fish can be harmed. So this is an objective to achieve. The AI system come up with a new self-multiplying catalyst that will do the trick with a very rapid chemical reaction. Great, but the reaction uses up a quarter of the oxygen in the atmosphere, and we all die slowly and painfully. So from the AI system point of view, the water is clear, fish is living wonderfully, and we are just a bilateral problem, right? So it is okay, which of course is not. So, and then we start asking other questions, right? So we have to think about everything, what the implication is for education. Will it take my job? We say no. But someone who knows how to use AI ethically and without risks more than you do may take your job. So we have to prepare for that. And here I'm going to introduce some more information in terms of historically, right? What we have seen is that technological revolutions create new jobs while transforming existing ones. This fear that we have so far have not extinguished jobs. Of course, there will be a process of transitions where there will be some difficulties to overcome. Literacy problems, for instance, in terms of educating people. So here I present an example, right? Moving from a university bridge blueprint done in 1915, hand-drawn. Yeah, we have projects like the Daedalus Pavilion. So the Daedalus Pavilion is inspired by a god in Greek mythology, which, well, it's an architect, in fact, that is always looking for improvement and And this pavilion symbolizes innovation, creativity, and cutting edge in design. And the Daedalus Pavilion is a groundbreaking project in AI because it showcases two elements of here, which is the design and the production method, right, based on robots. And each element of this structure that you see is no bigger or smaller than it should be, right? It's in perfect balance. So if you remove one element of this structure, however, it collapses. Yeah, but it just shows that we can use the minimum amount of material possible, which is sustainable, to create very wonderful new designs. So here I have another example of historic transformation. So in product design, we moved from manually created physical prototypes, which Stan was mentioning earlier, to AI-based generative design tools that produce thousands of product interactions in minutes, right? Suggesting optimized configuration for materials, weight, durability. And there's never going to be a solution that is better. There's always going to be some compromises, and then it's the role of the designer to understand that. Yeah, so this image was brought up by McKinsey, and they also say that this generative approach is no magic wand, as human expertise remain crucial for refining the outputs at the end of the day, so ensuring that practicality in achieving final product goals. And also another example in media and entertainment. Well, traditionally, those who worked in video production required manual labor-intensive work, such as frame-by-frame editing, sound leveling, color correction, right? Video editors now use AI-driven tools like Adobe Premiere, Sensei, and enhance footage and streamline production in a much faster way. So the common trend here that we see is that, is about optimization. And this is what deep learning models are trying to do, right? And while it does that, yeah, there's a need for us to rethinking the way we educate our students. There's a big however there. So because of this optimization, the introduction of generative AI tools like Midjourney, GPT, and so on, presents massive challenges in the education. These tools allows the students to instantly generate project ideas, visual concepts, and even full designs. So, and while this accelerated the creative process, it also risks bypassing critical learning stages. Yeah, over-reliance on Gen AI could result in students becoming passive users rather than active creators. And that is a main problem. Yeah, you become what you practice, and if you're not practicing thinking, what is important in the design, if you just become you become a master of prompting rather than a master of design. So how we go about then? What we think are the skills for the future? So I list here 4 critical skills for students. So the first one will be AI literacy, right? And that involves maths and programming, not to the extent that a computer science student would require, but if you don't know what is inside the black box, how can you explain or be assured that is delivering what you want and is not just coincidence? It's important ethical judgment as well. Designers should evaluate AI's social, cultural, environmental impact, ensure responsible and fair design practices. Another answer will be creative synthesis, which is about learning to merge AI-generated content with human creativity, transforming AI suggestions into meaningful solution. So basically, AI spit out a solution, and to actually, if you think that is good enough, that there is a problem, right? You should, as a designer, push the boundaries. And the last skill is adaptive learning mindsets. It's like what we call lifelong learning mindsets. And that's about learning to learn forever. Yeah, so technology will continue to develop faster and faster, and you should have that skill to learn, continue to learn. Because the tool of today will be outdated if you don't understand what the new tool tomorrow is. So then there's a risk that someone else will come and do something faster or different or improved, and then we have a problem. So in this, what are the educators' roles? Educators are rethinking their teaching approach, moving from technical training towards mentorship. Yeah, focused on creative judgment, contextual principles. In Mauricio, the report. Okay, so you can continue. There was a stop in the program. So no problem. And this help us to future-proof, right? That students in design education are living with the right skills. And here's just a suggestion what the design process should AI enhanced design process could look like. So AI assist idea generation, designers refine the concept that was generated with the help of AI. Prototyping testing is accelerated by AI, so you get this fast process, but the final presentation always relies on humans to finalize and curate. So basically, design AI will become the kind of a co-creator in future design studios if we learn the right skills, right? It should not replace designers. And getting to an end, close to an end here. So basically, it's always humans plus AI, right? That there's a fear in education that AI is going to replace us. No, it's you plus AI that will be able to solve complex design challenges. Yeah, the strengths of AI is computational speed and scale, and our strengths are cultural insight, empathy, creative intuition. Yeah, so then we have to navigate together, but there are challenges to that. The first one is the ethical considerations. Yeah, so bias and fairness, right? So when Juan was making his presentation, we could see that, the world is educated in different ways, and the software will always kind of perform in the way that the creator of the code creates the code, right? So therefore, we need to be able to pick up those things. Yeah, we need to be transparent about and disclose how AI contributes to a project. We have to understand the cultural sensitivity. Again, quite well illustrated with the work of Juan. And above all, there's a risk of data dependency and surveillance, right? What we call surveillance capitalism. Because the AI is data-driven, yeah, so there's a risk that we're going to be going mad for data collection. Yeah, and that is a risk. So we need to know where the data comes from, how it was collected in an ethical way. Do you know the sources? Yeah, so we start seeing new cases here, generative AI, Midjourney and Dolly facing copyright infringement lawsuits. Yeah, so you see on the left of both images, the real and then the AI generated images. Yeah, so and we continue that way. But up until this point, right? So this is where we are with AI. Yeah, but this is not like the future that the researchers are looking for. So the goal is what we call general purpose AI, or AGI, which is artificial general intelligence, which is capable of quickly learning high quality behavior in any task environment. So basically, is machines that can set up objectives, which current AI cannot. Yeah, you're familiar with that concept, right? So if you like movies like I do, sci-fi ones, yeah, so you've heard that HAL 9000, Skynet, the Architect Oracle in the Matrix, and all of those AIs that, they have ideas, wishes, and they perform. Most of them, tragically, they kill us in humanity. And so how far we are from that is speculative, this model, but they predict that 10 years, we may have something like that. And reasons why it may happen, the budget that is being invested in achieving AGI is about 10 times the Manhattan Project. And for those who are watched Oppenheimer, what was the development of nuclear power, is the Manhattan Project. It was equivalent to $23 billion. Yeah, 10 times that is $230 billion, which is half of the fortune of Elon Musk today, invested in this. So it may happen. We have more smart people. We're trying lots of new ideas. And it may not happen because we're running out of real data. Yeah, almost all the data that we have in the world is already almost being used. So then there's going to be stagnation and possible AI mega winter, which is people lose interest because we tested, doesn't work. So will it kill us? No, I probably not is the answer, right? We have to, if it's regulated, and governments start now regulating it, and if we look into the ethics and risks, it is in your hands as students and professionals to make sure you're using it ethically. So, and if it's created with right principles that protects humanity, it should be okay. In the past, every time we had a threat, it was regulated and it worked. So we should imagine that history will repeat itself. So, and if it does, so if you go back to the problem of de-acidification of the sea, the AI will ask us, do you like me to proceed, or do you like me to consider the oxygen? Yes, thanks for checking. We really would like to keep oxygen so we can breathe. Will it take my job when you get there, right? I hopefully I'll be retired at that point, but it may, yeah, it may not. We don't know. What we will know is going to happen, it will improve the quality of life for most people. Yeah, but that means that potentially will cause social change. And this is what you have to think about, because there will not be need for jobs, because tools, robots, and AI will do the jobs for us. So then we can invest our time in doing other things. And we need to be prepared for that. Yeah, so you're already familiar with that concept, which is when we don't have anything to do, so we start to explore in the universe, because we also killed our planet and we moved on. So, in conclusion, right? So AI in design education is not a disruption, it's an evolution, right? And embracing AI as a creative partner, educators can prepare students to become adaptive, innovative, and ethically minded designers ready for the future. So, thank you.
We have 10 minutes for this. So, want to start?
I have hopefully a quick question for Juan. I was thinking about your computational modeling, and you said, well, there's sort of a lower threshold, and if the machine is below that, it has trouble consolidating. Is there an upper threshold where it doesn't matter if I keep adding new agents?
So far, the limits are on the computational power
Okay.
to run the learning software. It's choosing a model from all the permutations of potential combinations. It's a very demanding process.
Yeah.
So it requires a large computer to do that. And also concurrently, like you can do that for one agent, but if you want to test that in a population, you need probably parallel computing running this simultaneously. So it's very demanding. But that's the challenge of reinforcement learning.
Yeah. Maybe you can apply for some time on whatever they call it, Big Blue or whatever. I know
Yes.
Yeah.
Thankfully, they are being more. We at Illinois have something called the National Center of Supercomputer Applications, and they get recently a nice grant for supporting faculty at the university with these kind of projects.
Oh, fantastic. Okay.
Yeah, so that's something it's in my list.
Okay, anyone? Ricardo?
I have a question to Juan as well. Juan, to what extent, I think you introduced it quite nicely, the kind of the way the mechanism, it has a kind of a bias because he considers the whole wheel as we see in the Western world. And do you see you could use other kind of frameworks, for instance, instead of color? What I was thinking in my mind here is that, like in Nordic countries, right? I know, for instance, they have more than 40 words to define snow, right? And then obviously, like possibly we have one or two the most, but that kind of shows that the problem of communication, isn't it? And how you form bounds based on being able to communicate with a high level of specificity and others with a much lower level. So do you see that what you developed could be replicated for different contexts?
Exactly. That's something I would love to try in like future iterations. Like imagine the part of the population have this Newtonian color wheel, and then other part of the population has something more like, let's say, their Scandinavian representation. So there's a different kind of like saturations or brightness in the colors. And the question there, and many different questions, is like, what's going to be the arrangement or the agreements between them? Maybe they have to give up some color spaces or part of the color space in order to interact with others. That's one thing, that is what's going to be the output. And second is, if someone is learning in that environment where you have different mental models, that's going to be someone who's going to come out with something that potentially is merging different models. And that takes me to the next question: is like, what if there's not a critical mass of these new agents? It's going to create a new world perception, a new potential model that it's not anticipated. Um, and so those are like spaces for research that I think with enough computational power we can fit there. But let me say something about this. And I found this methodology very informative in how biased are we designers when we are designing, because it's revealing this kind of like perspectives that are we take for granted when we're doing some research, maybe with the limitations of human-centered design, that we collect enough data that makes us, I like how Stan put it, enough information to make decisions, but probably not enough information to be fully informed about like diversity in the context. And these tools actually like help us to visualize that, or like to understand what if I have these other perspectives in the model. But I hope I answered the questions, Ricardo.
Yeah, you did. So it relates to what I was saying. It's super difficult to set up objectives when you have a multitude of variables that influence that, the completion of the objective. How far would you go in terms of saying, well, you have to consider this and that other, and that other. And this is why what the literature is saying is that AGI models will be able to do better than the current models, but it's still the final word will be ours, because it may not pick up on some elements that are so, like not data or structured data, in that way. So yeah, now it totally explained really well. Yeah, bias is a major issue.
I came across years ago, I was working with the oil industry on decision support systems. So how do managers make better decisions around oil mining? And I was shocked to learn, there's maybe 10,000 variables or constraints around the systems. And you just, as the person running the math, doing the linear algebra to come up with the decision optimization, you pick no more than a dozen out of all of those variables. So in what way can that ever be considered a kind of a reasonable, approach to decision support, right? Like and some of the variables they never include are people. It's always, number of trucks and how much, electricity and whatever. So it struck me that maybe, Juan saying, well, we can maybe start to apply some of these tools. I think you're right. I think the strengthening decision support is a pretty good candidate.
Yeah, well, it's not different in the construction sector. For instance, what we observed here is that there is a very limited innovative approach of the in general in designing buildings, because they may create a variation of form and layout of buildings type of thing. But in essence, like all the technology and a lot of the content inside is pretty much looking back and see, well, has worked in the previous one, it should work in this one. And it falls on that. If you keep doing what you always did, you're gonna get all what you always got. Yeah, and particularly when the construction sector is responsible for 2/3 of CO2 emissions. Yeah, in using buildings or in the construction of buildings itself, we cannot continue to do what we always done. So we need a massive change in behavior in the way designers think and regulations work, so that we can be more explorative in finding solutions that have never been tested before, and relying on simulation that is telling us it will perform better. Trust that and move on. So we're still not quite there yet.
Ricardo, there's a movie called Finch from Apple TV. Okay, I don't remember if you put in your list.
No, I didn't put Finch there. I don't know if I may. Maybe I did.
Yes, because there is a part of the film where the guy needs to move because there is a severe storm that's going to destroy his facility. And
Yeah, it is in my list.
Yeah, and he doesn't have time to teach his robot with all the huge database he needs to interact with the artificial intelligence of that robot. So that the robot needs to learn by itself. And with Finch, the protagonist of the history, it's a nice movie to understand how the machine is learning with the interaction with the human. But I saw a lot of potential with Juan Salamanca, the stand, and your presentations. And I was wondering, for example, Ricardo, you started a course with applying artificial intelligence in Bath, right?
Yeah.
I like to ask to Juan Salamanca and Stan in this direction. If it's time or mandatory, maybe in Illinois, in Urbana-Champaign, design course is already implementing some courses just like that. But I know that in my university, not. And I believe that we need something like that. We need I don't know, a new completely maybe a new undergrad course, just like Beth did, but everyone is working, for example, from my point of view, this year, maybe in the last 5 years, it was much more productive using ChatGPT than the others. And because I'm working with you, guys understand a lot. And we start dealing with that last year, right? So what do you think, what kind of, I'd like to hear a little bit your thoughts from Juan, Salamanca, Stan, and Ricardo about of this necessity of, if there is a necessity of our undergrad course to incorporate artificial intelligence. So in order to close our IICD talk.
Can I go first?
Yes, go ahead.
They already have Mauricio. That is the issue, right? So when it's just I go down to the studio just here in front of me, right? And they're using it all the time, yeah. And the issue for us is like we do want them to embrace it, but I think they are using it in an unsupervised way without understanding the consequences, right? It is quite addictive, right? Because the higher education environment is a stressful environment these days. It's very different from when you and I and Stan and went to universities, where like they have different pressures. They are exposed to a lot more information, and with that to a lot more misinformation. Yeah, it's quite tempting just get a tool that gives you a quick answer to something because you alleviate some time pressures that you have. And that goes back to what I was saying. So, like, we need to what we here in Bath, what the first thing that we've done was not to how to use this AI tool or that AI tool. We revised our ethics and our research, what we call we do an integrity test, right? We've revised our material so that the students are aware that there is an issue of copywriting or using that. There's an issue of like you're not learning some key blocks that are essential to become a designer if you're delegating that to a software which you don't know how it's operating. The skills that you need to keep you in a job will going to go away, right? And while we're doing that, now we're doing a review of, hey, okay, what are the skills that we need to implement and where, in which year? So that is, step by step. Yeah. So we're having now a major problem. We would want to believe that our students are all brilliant and they are not using it, or they are telling us they're not using it. But at the moment, we are in that trapping that if they wrote an essay with the support of a large language model, yeah, we cannot prove it's been written by that. Yeah. So we can only rely on them telling us the truth that I have used this way and I adapted from there. Yeah. So, and then it might be that if they're not telling us because they're scared of getting a low grade or something like that, which we said is not the case. We need just to know how you're using. So, because that problem we can fix. Then there is a much bigger problem in kind of like relate to honesty and what they are presenting to us. They're pretending they are learning, and we're pretending they are marking what they learning. So, and I'll leave it there. So it's a major issue. It needs to be embraced by academics and by students as well.
I can share. I mean, from my experience here in Illinois, I tell you that we don't have a class that I think we should have in design. There are other classes about these aspects of AI and ethics and in other schools, but in our design school, don't. And we lack of that. Of course, there are classes that are now embracing the idea of like prompting to have assistance, digital assistance in the design process. Um, and it's very easy and enjoyable to like do design with that kind of like methodology, just a couple of like words and like refining the prompt and trying to get some images that are could be incorporated in the design process. And that's pleasant, and I think it's effective, and it's gonna remain there. It's something that we should embrace and accept. But in my opinion, there, I think Ricardo says something that is important. Is like, to what extent do we need to become masters of prompting rather than masters of design? And what is the difference between the two of those two? If we learn how to be a master of prompting through the process of designing, I don't think that make us really good designers. We could still good prompt engineers. So what is, on the other hand, is what makes us a good master in design? And I think that that is something that we need to reflect at a more epistemological level. When we are prompting and getting an output, a list of potential ideas, is that what we're looking for? If I embark in a research process, is it that I am anticipating what I'm looking for and I'm getting what I'm expecting? Or is the machine telling me this is what you're looking for? So instead of like answering the question I am trying to explore, the machine is giving me the framework of my question. And I'm conforming my question to what the machine is giving me. And I think that is, if we are really masters of design, we need to have the capacity to reflect on this. To what extent I am just subrogating the conceptualizing process to the machine instead of like being really the judge of what is the output of the machine. But I think it's a very deep reflection on like the epistemological processes, ontologies, like deep question on what is being a designer.
I would say, just to add one last reflection quickly, one of the inputs that I almost never think to include is anything about human-centered information. It's not like I've gone out and studied the people that I need to work for, and then I tell the machine what I've learned and then ask it to produce something. I'm not sure it could even take that kind of input in the way that they're currently configured, right? It sort of assumes it already knows, from its training.
Mm-hmm.
So that could be something as we start to develop tools that are AI for designers, that one of the inputs that it's going to rely on is the research we do with people.
And just sort of as an example, there's something that really concerns me is how industry is taking it, right? And I find it almost like replicating the mentality that we see now in the studio here, in that the way I phrase it is like computers cannot conceptualize totally novel ideas, right? It will need something behind. So they are very good at storing data, processing the data that we put on. Yeah, and then we had a firm that we had issued an insight doing some research with them, and they were working on they using a particular software, AI driven software that could generate. It's a generative AI solution where it was generating hundreds of solutions for multi-building site implementation. Yeah, and they had a baseline to understand how much time people spend on the tasks of creating and on the tasking of producing drawings. Producing drawings is just spitting out information that shows how it's going to be built. So it does not add value, but is not the core thing. Yeah, and then in that particular company, it was about 80%, and this number, 80% of these low value adding generation tasks happens in many different types of design. Yeah. And then we thought, well, great. So you can save time of this 80% of producing drawings because they're not added value. And then that amount of time can be shifted to design conceptualization, because usually when the company is under pressure, they rush to conceptualize something that is ill thought. It's not good enough. But what we found is that because that company was paying designers by the hour, they actually did not increase the amount of time given for conceptualization. They just used that as a standard, yeah, and got the benefit of optimizing a concept that was poor in principle. So, and that scares me. Right? That is, I'm going to earn so much money, I have to pay less to designers because they're going to, it's 20% of the time that they need to create an idea. And that is problematic. So a good concept takes a lot more time. It's different from production, right? In production, optimization means to reduce the amount of time. In design, sometimes is making the time longer because you optimize the solution with much larger benefits in the long term. So, and I think this is the paradox that we have to deal with our industry partners at the moment.
Guys, thank you so much. So wonderful discussions, wonderful presentations. I wish we could meet together presentially in the future. Who knows? There are going to be another grant foundation. Yes. Who knows? I've already talked with Juan Salamanca, with Sam and Ricardo, maybe in 2025. Okay. Oh, we have Nizia. Okay, Nizia doing okay. So I have to end our talk. Thank you so much for the presentations. I will release the recording up to tomorrow. Okay. Thank you.
Mauricio, just a quick question. I saw a message popping up on the screen, but I cannot see who sent it.
A message for the chat.
Yeah.
The chat.
Someone is like, "Hi, Professor," or something. I was going to send an email, but
Okay. I don't know who was
no.
because I had a problem with the connection and maybe I lost. But okay.
We found out at some point.
Okay. So I'm going to stop recording and I'm going to wish you all a wonderful week. So at the next IICD talk. Bye bye, everyone. Thank you.